So this session is related to organic chemistry. Yesterday I started alkanes, but before alkane I should explain this topic because we should have understanding of organic chemistry, and then we'll start alkane again after completing this topic. This is mainly the introduction of organic chemistry, the things which are related to organic chemistry. First, the definition, the basic definition. Hydrocarbon, how we define a term: hydrocarbon compounds which contain carbon and hydrogen, only they are known as hydrocarbon. What is the meaning of saturated hydrocarbon? A hydrocarbon which contain carbon-carbon single bond, we call them as saturated, and unsaturated, if they have a double bond, we call them as unsaturated. What is the meaning of molecular mass? The molecular formula, basically the molecular formula which represent the actual number of atoms present in the structure. Example, if we have, like, there's a structure which is having 3 carbon atoms and it is having 8 hydrogen. So the formula which we use to represent the number of the carbon and hydrogen, we call that as molecular formula. So there are 3 carbon atoms and there are 8 hydrogen atoms, so the formula is C3H8. And what is empirical formula? The formula which represents the simplest ratio. So if we have the structure, and we are representing all the bonds. So there are 4 carbon atoms, and when we count the number of hydrogen, it will be 10. So C4 and H10, that is a molecular formula. But what is empirical formula? The empirical formula which represents the simplest ratio between the atoms. So the simplest ratio of 4 and 10, that is 2:5. So C2H5 will be the empirical formula. And what we call this structure in which we represent all the bonds and the atom, that is known as the displayed formula. If we represent only like group of molecules in the structure, like the same one, if it was written, when I represent all the bonds, so 4 carbon atoms are there and there are 10 hydrogen. So this is called a displayed formula. This is called a molecular formula which represent actual number. Empirical formula which represent a simplest ratio C2H5. And what is the structural formula? In which we don't represent all the bonds, we just explain the geometry, like the part of the molecule. So 1 carbon and 3 hydrogen, so I can say CH3. Then 1 carbon 2 hydrogen, I can say CH2. 1 carbon 2 hydrogen, I can also say CH2. And 1 carbon and 3 hydrogen, I can say CH3. So when I just represent the molecule in terms, the whole structure in terms of part of the molecule, what we call that as, we call that as structural formula. And if we represent only the carbon and the functional groups by the lines, we call that as a skeletal formula. So 1, 2, 3 and 4. So when I display, like, this is the first carbon, second, we don't have to write the number, we just represent the skeleton of the molecule. So we call that as skeletal formula. So we can have a displayed formula. Why it is important to know all these formulas? Because it depends on the question. Sometimes they say draw displayed formula, structural formula, skeletal formula, or write the molecular or empirical formula. Is it clear the difference between different types of formulas which we use to represent the organic molecule? Then what is a homologous series? A homologous series a series which explain the idea that each molecule differ by CH2, physical properties gradually change, chemical properties are same, and they will have the same functional group. What is the meaning of functional group? The term functional group means it's an atom or group of atoms which are present in different molecules. They have the similar chemical properties. So we call that as the functional group, or the atom or group of atoms which totally change the property of the molecule. We call them as functional groups. So the functional groups which you have to learn, there are different functional groups. We'll discuss throughout how to write the name for these functional groups as well. First one is how to write the name, how to name the structure. So when we have a displayed formula, the first thing, what are the rules of naming the hydrocarbons? The first rule, we count the longest carbon chain. Select the longest carbon chain. That's the first way. So example, as you can see, the first structure, if you want to name, so if I, and we can count from anywhere. If I count 1, 2, 3, 4, so maximum 4 are there. If I count from here 1, 2 and 3, maximum 3. So this cannot be a longest chain. But if I count from here 1, 2, 3, 4, so maximum 4 are there. So any way I can count. So first we select the longest carbon chain, and then the numbering should start from nearest branch. So if I count from here 1, 2, 3, 4. So, and there's also another way I can count these carbon atoms. I can count as 1, 2, 3 and 4. But if I count 1, 2, 3, 4, the branch is coming at 3. The carbon which is not included in the numbering. And if I count from the left hand side, the carbon is there which is coming at the second. The branch is coming at the second, or the carbon which is not included in the numbering is with second. So the first rule, we select the longest carbon chain. Then numbering should start from the nearest branch. And according to the branch, we use a prefix. As we can see, there's only one branch here. Means the branch is having one carbon. So when there's one carbon, what is the name used for that? That is meth. So the position, first we have to position. Second position, we have a carbon, one carbon in the branch. So it is 2. Meth because of 1. And YL because it's an alkyl or a branch is there. So it is called methyl. So 2 methyl. And there are 4 carbon atoms. So when 4 carbon atoms are there, what is the prefix used? That is but. Because they have a single bond throughout the structure, so we call that as ane. So actually it is 2-methyl butane. Is it clear? The first example, the name of this compound. The first one, we select the longest carbon, then the numbering should start from the nearest branch or the functional group, and then we name the branch first and then the whole structure. Same way, if you check the other one, so when we try to find the maximum carbon, this is one way, 1, 2, 3, 4, 5. Or if we count 1, 2, 3, 4, 5, 6. Or 1, 2, 3, 4 and 5, 6. So maximum we are getting 6 carbon. But in this case there are 7 here. As you can see, if I count from here 1, 2, 3, 4, 5 and 6, 7. So this appeared to be the longest chain. And what is not included is considered as a branch. So what I circle here is the branch. So how many branches are there? There are two branches. So if two branches are there, two identical branches, we use the term di. If three identical branches are there, we use the term tri. And if four identical branches are there, we'll use the term tetra. So when we start the numbering, if I number from here 1, 2, and 3, 4, 5. So third position I have a branch and fifth position I have a branch. If I number from the top 1, 2, 3, 4, 5. So again third position and fifth position I have a branch. So it does not make difference anywhere. I can start this numbering. So we have the branch at third position. That's why we write 3. And we have a branch at fifth position. So we write 5. There are two identical branches are there. That's why we use the term di. And one carbon in each branch. So meth because of one carbon. And YL, it's a branch. Then there are 7 carbons. For 7 carbon, we use the term hept. And throughout the structure, there's a single bond. That's why it is used as ane. So it is 3,5-dimethyl heptane. Is it clear? This is structure. And the naming of this hydrocarbon. Any doubts? So this is the table which you have to learn related to a functional group. We will discuss each functional group. So if we have alkene, it means there will be a double bond. The name should have, the suffix will be "ene", means at the end we'll place "ene". Example 2 carbon, it's eth. Because of the presence of double bond, it is ene. So it is ethene. What about alcohol? Then if it is alcohol, the alcohol means it contains OH. So alcohol means it contains OH. The name should end at OL. If we use a suffix, like if we are using at the end, then it should be OL. But if we are using a prefix, it should be a hydroxy. And example here, there are 3 carbon atoms, 1, 2, 3. For all these functional group, we'll do in detail. The practice will in detail. This is just an introduction of the functional group. That's why only one example for each is shown on the screen. So 3 carbon atoms are there. It will be prop. Single bond between them, it's N. And functional group, the OH is positioned with the first carbon. That's why it is written 1-ol. So propan, 1-ol. What about halogen alkane? It can be chlorine, bromine, or iodine. If chlorine is there, we'll use the term prefix chloro. Bromine is there, we'll use the term bromo. And iodine is there, we'll use the term iodo. And if we are using as a prefix, first carbon is having a chlorine. So it is 1 chloro. It is 1 chloro. And because there are 3 carbon atoms, so we use the term prop. They have a single bond. So if they have a single bond, it will be N. So 1 chloropropan. What about aldehyde? What is the meaning of aldehyde? Aldehyde means it contains C double bonded with O and H. Or we also say CHO. The name of aldehyde, if it is using as a, if we are using as a suffix, it will be al, and if we use as a prefix, then it will be formal. But normally we use as a suffix. So as you can see, 2 carbon atoms are there. It is eth. Between the two carbon atoms, there is a single bond, it is N. And due to this C double bonded with O and H, that is all. So it is ethane all. What about ketone? Ketone means C double bonded with O is there, which is attached with a carbon chain both sides. Aldehyde is always at the end, but ketone will be there in the center, and the name should end at ON. If we use a suffix, normally suffix is used ON, but if it is used as a prefix, then it will be oxo. So three carbon atoms are there. Because of the three carbon atoms, we call that as prop. They have a single bond, that's why it is N. And due to this C double bonded with O, it is on, so it is propane on. About the carboxylic acid, that is C double bonded with O and OH or COOH. The name should end at oic acid, it will always be a suffix. And this is always the first carbon, so we don't have to number it. It is always attached at the end. So two carbon atoms, that's why it's F. Single bond between them and due to this functional group, it will be oic acid. If nitrile group is there, it means carbon triple bonded with nitrogen and then it is attached to a carbon chain. So if we use as a suffix, it will be nitrile. If you use as a prefix, then it will be cyano. So there are three carbon atoms. You can see 1, 2, 3. That's why it's prop. They have a single bond. That's why it is N. And what about nitrile? Because of this C triple bonded with N, that group is known as nitrile group. What about amines? When nitrogen is attached with a carbon chain, we call that as an amine. If it is used as a suffix, we use the term amine. And if it is a prefix, we use the term amino. So there are three carbon atoms. So that's why we call prop. They have a single bond N. And because first carbon is having a amine group, so we call that as one amine. So propan, one amine. About the esters, they have C double bonded with O and O. The part which is attached with oxygen we name first, and the part which is attached with the carbon we name that second. So this part is attached with oxygen. So one carbon, it is methyl. And the part C double bonded with O connected, that's eth because of two carbon. N because they have a single bond between the carbon, and O8 is used for esters. Acyl chloride, when C double bonded with O and Cl, we call acyl chloride, and name should end at oil chloride. So example here, two carbon atom at single bond between them and oil chloride, because of this functional group C double bonded with O and Cl. And amide means C double bonded with O and NH group, we call amide. So there are two carbon atoms, we call eth, single bond N, and because of C double bonded with O and N, we call that as amide. So these are the functional groups we'll study in this syllabus related to organic chemistry. Any question or a doubt? So I just give you example there because there is a way to name each of them that we'll discuss in detail. But these are the functional group, so you should be able to recognize by looking at the structure. Any question or doubt at this point? Okay, rules of naming the functional group. Example, the functional group is indicated by prefix or suffix. Example, chloroethane is there, it means chlorine is there. So how to name? First, what we have to do, we have to count the carbon atoms and the numbering should start from nearest functional group. So if these are the carbon atoms, if the functional group include a carbon, we'll count that as well. So when we count here 1, 2, 3, 4. Fourth position OH, if we count from here 1, 2, 3 and 4. First position OH. So there are 4 carbon but. They have a single bond and because OH is attached with the first carbon and whenever OH is there, that is called alcohol, and alcohol, the name should end at OL. So it is butan 1-ol. And one more thing, when you are naming the functional group, some cases we remove the E and some cases we do not remove the E. Like example, A and E for alkane is there. Sometime we remove this E and sometime we are not removing this E. So when a suffix add into the following way, like example, if the suffix start with a vowel, we will remove E from a stem of alkane, alkene or alkyne, like propanol or propane 1-ol. So functional group, the suffix is starting from vowel. So we have to remove amine, oic acid, oil chloride, amide. So in all the cases you can see, even though there is a single bond, but we don't represent by A and E, we just represent by AN only. But if the suffix start other than the functional group or other than the vowel, or for example any number is there, we do not remove the E from a stem. Like example, alkane is there, so we write complete. So prop, propane. So we did not remove this E here. We write full prop ANE and then nitrile. Eth ANE and 1,2-diol. Because di D is there, it's not a vowel, so it is starting with, not starting with a vowel, that's why we write full. Same thing, propane. We write this E because it is dioic acid, not oic acid. If for the oic acid, we'll write prop and oic acid. But because it is dioic acid, so di is there. It's not starting with D, O, it is starting with D. That's why in that case, we do not remove the E from alkane. So prop, because it is starting triol T, so that's why we did not remove this E. Dione, it is starting with D, that's why we are not removing the E. So when it is a vowel, then you will remove the E. If it is not, you don't remove that E. So some functional group take distance over the branches and we give them the lower number. Like example, as you can see here, 3-methyl butane is correct, but not 2-methyl butene. What does it mean? Uh, because butane and 3-methyl. So when we number this, numbering just should start from the nearest. Uh, like if I number from here, right hand side 1, 2. So second position, I have a branch. But if I number from the right hand side, 1, 2, 3, 4. Sorry, number from left hand side, 1, 2, 3, 4. So first position, I have a functional group. So which one we give a priority? We give the priority to the functional group compared to that branches. So that's why when we count this, it will be 3-methyl because third position we have a branch, so 3-methyl butane as compared to 2-methyl butene. So always we try to give priority to the functional group. If we have 3 identical branches or 2 identical branches, we use the term di. If 3 identical branches, we use the term tri. And 4 identical branches are there, we use the term tetra. And note that the point above, that addition of a E, like if there is a vowel, we write E. If there is no, we don't write that. If vowel is there, we don't write. And if it is not there, we write that E. And how to separate the words? So words are separated by numbers with the dashes and numbers are separated by commas. So like some student write two So they're writing, separating the number by dash. That is wrong. When you separate the numbers must be separated by commas, and the words are separated by dash. And word and number